Imagine spending more than 20 years exploring the most violent explosions in the universe, only to discover that your greatest enemy isn't a black hole. It isn't a supernova. It isn't even deep space. It's Earth. Right now, hundreds of kilometers above our heads, one of NASA's most successful space telescopes is slowly falling toward our planet. Every second, every orbit, it loses a tiny amount of altitude. If nothing changes, this remarkable observatory will eventually plunge into Earth's atmosphere and burn up forever. But instead of accepting its fate, NASA has decided to attempt something that's never been done before. Not a mission to Mars, not another moon landing, a space rescue mission. And if it succeeds, it could completely change how we explore space for the next century. The spacecraft at the center of this story is the Neil Gehrels Swift Observatory, launched by NASA in 2004. Its mission was simple, but incredibly ambitious. Whenever one of the most powerful explosions in the universe occurred, Swift had to find it before it disappeared. These explosions are called gamma-ray bursts, and they're almost impossible to predict. Some are created when massive stars collapse into black holes. Others happen when two neutron stars collide. In just a few seconds, they can release more energy than our sun will produce during its entire 10 billion-year lifetime. To catch these fleeting events, Swift was designed to react with astonishing speed. The moment another observatory detected a burst, Swift could automatically rotate toward it in minutes, capturing precious data before the cosmic explosion faded away. Over the last 2 decades, this telescope has helped scientists study black holes, exploding stars, neutron stars, and some of the most energetic events ever observed. It has contributed to thousands of scientific papers and transformed our understanding of the violent universe. But while Swift was looking outward, something unexpected was happening much closer to home. Most people imagine space as a perfect vacuum, completely empty. But that's not entirely true. Even hundreds of kilometers above Earth, there are still tiny traces of our atmosphere. Normally, they're so thin that satellites barely notice them. But our sun has a habit of changing the rules. Every 11 years, the sun goes through a cycle of increasing and decreasing activity. During its most active periods, enormous eruptions of energy heat Earth's upper atmosphere. And when that happens, our atmosphere expands. Imagine heating a balloon. As the air inside warms up, the balloon grows larger. Earth's atmosphere behaves in a surprisingly similar way. It stretches farther into space. Satellites that once orbited through almost empty space suddenly begin flying through a slightly thicker layer of atmosphere. The difference is tiny, but over thousands of orbits, it becomes impossible to ignore. Imagine riding a bicycle while someone gently presses the brakes. You don't stop immediately. You simply lose a little speed with every second. That's exactly what's happening to Swift. Each orbit steals a tiny bit of energy. Each day, it falls a little lower. And unless someone intervenes, gravity will eventually win. For decades, the solution seemed obvious. When satellites began losing altitude, they simply fired their onboard engines and climbed back into a higher orbit. But there's one problem: fuel. Every satellite carries only a limited amount, and after more than 20 years in space, Swift's reserves are running dangerously low. For most of spaceflight history, that would have marked the end. Scientists would retire the telescope, launch a replacement, and move on. But this time, NASA asked a very different question. What if instead of replacing a perfectly working telescope, we could rescue it? And that single question has led to one of the boldest experiments in modern spaceflight. To answer that question, NASA partnered with Katalyst Space Technologies, a private aerospace company developing a new kind of spacecraft. Its name is Link. At first glance, Link doesn't look extraordinary, but what it's attempting has never been demonstrated on a government science observatory before. Think of it as the world's first orbital tow truck. Its job isn't to explore another planet. It's to chase down an aging spacecraft already racing around Earth at nearly 28,000 kilometers per hour. That might sound impossible. After all, how do you catch something moving that fast? Surprisingly, the answer is by moving just as fast. Both spacecraft are orbiting Earth at roughly the same speed. The real challenge isn't speed, it's precision. Imagine trying to step from one moving train to another while both are traveling hundreds of kilometers per hour. Now imagine doing it without a driver, without GPS, and while floating in the vacuum of space. That's orbital rendezvous. One tiny mistake could send the spacecraft spinning away forever. or worse, damage the very telescope it's trying to save. That's why engineers spend years testing these maneuvers before launch. Every movement is calculated down to the smallest fraction of a second. If Link reaches Swift successfully, it won't simply fly beside. It must slowly approach, match its motion, carefully connect, and then gently push the observatory into a higher, safer orbit where atmospheric drag is much weaker. No dramatic explosions, no powerful rocket burns, just an incredibly delicate operation performed hundreds of kilometers above Earth. If it works, Swift could continue studying the universe for years beyond its expected lifetime. But the real story isn't just about saving one telescope, it's about changing the future of space itself. Right now, thousands of satellites orbit our planet. Many stop working not because they're broken, but because they simply run out of fuel. Others become abandoned pieces of space junk, increasing the risk of collisions in Earth's crowded orbits. Today, there are tens of thousands of tracked objects orbiting Earth, ranging from active satellites to old rocket stages and debris. Even tiny fragments can travel at speeds fast enough to damage spacecraft, making orbital traffic an increasingly important challenge. For decades, humanity has treated satellites almost like disposable electronics. Launch them, use them, replace them. But what if we stopped thinking that way? Imagine spacecraft that could be repaired instead of abandoned, refueled instead of retired, upgraded instead of replaced. A damaged communications satellite could receive new components. A scientific telescope could have its life extended. Even future missions to the Moon or Mars might rely on spacecraft that are serviced again and again, rather than discarded after a single mission. In many ways, Link isn't just testing a rescue mission, it's testing an entirely new philosophy of space exploration. Of course, success is far from guaranteed. Space is unforgiving. A software error, a navigation mistake, or a mechanical failure during docking could end the mission. That's why NASA describes this as both a rescue mission and a technology demonstration. Whether Link succeeds or not, engineers will learn lessons that could shape how future satellites are designed and maintained. It's remarkable to think that after spending more than 20 years helping humanity understand the most violent explosions in the universe, Swift now needs a rescue mission of its own. Not to discover another galaxy, not to observe another black hole, but simply to survive. And perhaps that's the biggest lesson this mission has to teach us. The future of space exploration may not be defined only by the new spacecraft we build, but by how well we care for the ones we've already sent into the stars. Sometimes, the greatest exploration isn't about going farther. It's about making sure our greatest discoveries get the chance to continue.